All right, in 8.4, we are going to continue what we're doing with sine, cosine, and tangent. We're applying angles of elevation and depression. Okay, first we have the definition of each. So an angle of elevation is the angle formed by a horizontal line and a line of sight to give a point above the line. In the diagram, angle 1 is the angle of elevation from tower T to the plane, and an angle of depression is the angle formed by a horizontal line and the line of sight to a point below the line. Angle 2 is the angle of depression from the plane to the tower. So as we see, we have our line of sight here, and the angle of depression goes down, and then we have our line of sight down here, and the angle of elevation goes up. Okay, since horizontal lines are parallel, angle 1 and angle 2 are congruent by the alternate interior angles theorem. Therefore, the angle of elevation from one point is congruent to the angle of depression from another point. So here we have angle 1 and angle 2 are congruent. All right, our first example, classify each angle as the angle of elevation or an angle of depression. So angle 1, what do you think this angle is?
The angle of depression.
So it's going down, so it's depression. What about angle 4?
No, wait. Elevation.
Elevation.
I meant elevation.
Because it goes from like the line of sight of the base of the tree and it goes up.
Wait, are we talking about the line of the floor or the line above?
The line, well, we're talking about the angle. This angle here. This angle. All right, now we have a couple more examples. What about angle 5?
Ooh, that's a
Depression, perfect. And angle 6?
Elevation.
Elevation.
Is this all we're doing for the whole thing?
No.
Oh.
Oh, man.
Okay, 2 more examples like this. Classify each angle as an angle of elevation or angle of depression. So angle 6.
Depression.
Wait, what do you go based off of, right to left?
No, like if the angle goes down, then it's depression. If it
So we
goes
go
up,
from the line of sight and see if the angle goes down or up. So this one's going down, so it's depression.
Oh, that's not what I thought that was. Okay.
And then angle 9
Elevation.
is elevation. So we go from the straight horizontal line and it goes up. So it's elevation.
Yeah. Favorite off is gonna be depression elevation. Is that it?
Oh my god.
All right, so now we're applying this. So the Seattle Space Needle casts a 67-meter shadow. So this is the Space Needle, Y, and its shadow is 67 meters. So if the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? Round your answer to the nearest meter. So here is our angle of elevation, the 70 degrees. We need to find how tall the Space Needle is, so we need to find Y.
But like why?
We already have a formula to find that.
Yes, we do.
The Pythagorean theorem.
SOHCAHTOA.
Oh, so we really have to know that?
So you really have to know it.
I wrote my own.
There's no hypotenuse, so we have to use tangent.
What about AB? Isn't that the hypotenuse?
It is the hypotenuse, but it's not asking us to find that.
Oh, so if we're
So,
we don't have a measure.
right, we're using this angle, angle A, it gives us the adjacent, and we're looking for the opposite. So we have to use the one that involves the A and the O, guys. Cut it out. So we have to use TOA. So we're going to use the tangent of 70 is equal to, what is the opposite?
Y.
Y. And what's adjacent?
67.
67. So again, you need your calculators for this.
Oh.
So we can multiply both sides by 67. So we get y is equal to 67 times, that's a y.
Oh. I was confused.
So in your calculator, you're going to put tan of 70 times 67.
I got 183.58.
84.
It rounds to 100.
Perfect.
Meters, or
Meters. So this is our final answer, 184 meters.
Ahsoka Toa.
Okay, an ice climber stands at the edge of the crevice that is 115 feet wide. The angle of depression from the edge of where she stands to the bottom of the opposite side is 52 degrees. How deep is the crevice at this point? Round the answer to the nearest foot.
I'm using the Pythagorean here.
We can't use the Pythagorean theorem here because we don't have two side lengths to use it.
Well, 52
Is a degree.
is.
So that's the angle. So how do we find what?
well, there's not like
So we have a parallel line here and a parallel line here, right? Do we know what the angle of B is?
No. Oh, yeah.
Can we figure it out? Right, we have this angle and the alternate interior angle is also 52.
Yeah.
So that makes B 128, right?
B is 52 because they're the same.
Oh,
But angle CB.
never mind, I was looking at something else.
Yes. Yes. Because if we have this triangle here, 52 plus this part is going to be 90. So now that we have this angle, we're looking for what's opposite and we're given the adjacent. So what involves opposite and adjacent?
And
TOA. So we need to take the tangent of what?
52.
And that's going to be equal to
Y over 150.
y over 115. So if we multiply both sides by 115, they'll cancel out on the right. So we get y is equal to 115 times tangent of 52. And what do we get for y?
147
Point two rounded.
0.2 rounded.
We'll just leave it as 147. Does everyone agree?
0.2.
Round to the nearest foot.
Oh, shoot. But like, couldn't it be like, oh, never mind. You're right. I'm sorry.
Yeah.
No, I'm sure.
Yeah, I got 140. Oh, wait, no. I got 146.05.
So round to the nearest foot.
146.1.
Somebody must have rounded, so that's why it's a little off.
No, oh, I got 0.05 though. Not like.
But it's just a little off, so like there was somebody rounded. So either Austin rounded it or you did. So one of them's a little off. But it's
Put
close
140
enough.
I just put 146.
You can put, yes, close enough. Okay. An air traffic controller at an airport sights a plane at the edge of elevation of 41 degrees. The pilot reports that the plane's altitude is 4,000 feet. What is the horizontal distance between the plane and the airport round to the nearest foot? So here we have to draw our triangle.
I love drawing.
So we have an air traffic controller at an airport. So
It's a square. Air traffic.
this will be our air traffic controller.
Huh.
little guy.
Stick
Aw,
man.
he's so cute.
Hey.
A plane is at the angle, so he sights a plane at an angle of elevation of 41 degrees. So our airplane's gonna be up here. I don't know how to draw an airplane.
Just make like a oval.
Draw a bird.
It looks like a person.
Just make like an oval kind of, and then like
Yeah, two
make,
wings.
and then make 2 ovals on the side.
So master.
It looks like a fish now.
It's kind of like a pickle.
Yeah,
Close enough.
it is.
Okay, so our angle of elevation is 41. So we're gonna draw a line from our ground up to the top. And this is gonna be 41 degrees.
So he's like looking that way, like the line of sighting, whatever you said.
So he's looking at the airplane at an angle of elevation. So it's gonna go up because he's looking up at the airplane. So this is like his line of sight here. And what is the height of the plane?
4,000 feet.
4,000 feet. And it's going to form a right angle with the ground. So we're looking for the horizontal distance between the plane and the airport. So we're looking for this distance, which we'll call it x.
So can you do
How do you know to use
If
the
it's opposite, wait, no, opposite.
Because it says,
It's Toa, right?
what is the horizontal distance between the plane and the airport?
so you can use Toa, right?
So we need to use TOA because it gives us the opposite and adjacent. So we're going to do the tan of what?
41.
What's the opposite?
4,000.
44,000.
And what's our adjacent? X.
You multiply both sides by X.
So we can multiply both sides by x. So we get x times tan of 41 is equal to 4,000. And then we need to divide by tan of 41. So we get x is equal to 4,000 divided by tan of 41.
Will that be on the test? You don't have to wait. Never mind. It's
Are you
gonna
sure?
calculate.
So now you need to put this into your calculator.
Oh, I thought we had the multiply.
Is there a way to do that with no calculator?
No.
Got a number greater than 4,000? Is that?
You got 869.2.
Yeah. Calculator got 4,601.
So that sounds pretty personal to me.
What, if what, 869 0.
You round the number and explain it to him?
Yes.
I got 4,600.
It says round to the nearest foot. So if you got 4,601, close enough.
4,601. Yeah, I got it.
I just looked up calculator and downloaded the first one.
I got 4,500.
Yeah, that's a PDA numeric.
You probably just rounded in your calculator,
Even though he likes
so that's why it's a little off.
So would that be right?
Yes.
This is the last one. So, Stuart,
All right, last example. A woman standing 12 feet from a sculpture. A woman is standing 12 feet from a sculpture. The angle of elevation from her eye to the top of the sculpture is 30 degrees, and the angle of depression to its base is 22. How tall is the sculpture to the nearest foot? So we have a lady who's standing 12 feet from a sculpture. So here is our sculpture. The angle of elevation from her eye to the top of the sculpture is 30 degrees. So if we drew a horizontal line to the sculpture and her eyesight's going up to the top of it, this angle here is going to be 30 degrees. The angle of depression to its base is 22. So where would that 22 degrees go? Down from where?
From there, from the, like, the mother, right?
From where to where?
Say, like, isn't it from the bottom of the triangle all the way down to the bottom of
From here to here?
Oh, snap.
it? Okay. there.
Perfect. So this angle from her eye to the top of the from the angle of depression from her eye to the bottom of the sculpture is 22. So we need to find out how tall the sculpture is.
Would we do the tangent of 12 feet? Or wait,
What is the alternate?
Pythagorean theorem.
Can't do the Pythagorean theorem because we don't have two side lengths.
So I have to go to that too.
Don't we put X? Oh,
wait, wouldn't it be the?
Oh, isn't like the thing on top of 12x?
Wait, would it be
Don't you just do proportion? Like
Would it be
30
the
over
cosine
22 and then
thing?
x over 12?
No, because our triangles aren't congruent.
Ah,
Would it be
I had
cosine?
something.
So let's take one triangle at a time. Let's look at the top one.
Oh, you can do it one by
Can we draw a smiley face on the guy?
It's a girl, but yes, we can draw a smiley face on
Can
her.
we draw a smiley face on the non-binary?
You have to draw like, you have to give her hair.
So if we're trying to find the height of the sculpture, let's call this part x. What can we do to find x?
Toa.
Opposite.
Toa, because it gives us the adjacent and we need to find the opposite. So we do tangent of 30 is equal to what?
X over 12.
X over 12. So we just multiply 12 by both sides. So we get x is equal to 12 times tangent of 30.
Wait, what do you do with the 22 then? Or you just.
One step at a time. You said we're going to solve the top triangle first.
7.
Then what's?
I got
is it a
6.9.
It's 7.
Congratulations.
So you find the tan of 30 and then multiply that by 12.
7.
7. Everyone agrees?
What?
Chapter.
What?
Oh, mine's 6.9. That's basically.
Close enough.
Are you like,
That's basically.
Okay, now we need to find the bottom triangle.
you gotta do the same, you
Pythagorean
gotta do the
theorem.
same thing.
So let's call this part y.
You gotta do the same thing.
And we're going to do the same thing. So are we going to do tangent again?
Yes.
Yes. So tan of what?
Tan of 22 equals y over 12.
Perfect. Y over 12. We can multiply both sides by 12. So we get y is equal to 12 times tangent of 22.
5.
And y is equal to 5. Everyone agrees?
Yeah.
You got it.
Yeah, I get it.
So our top part of the triangle, of the sculpture, is 7. And the bottom part is 5. So how tall is our sculpture?
12.
12 feet.
12 feet.
Doesn't it say it's 12 feet?
No, she's 12 feet from the base. She's standing 12 feet from
Oh,
it.
that's like such a troll that they like. give
Is
you
it gonna
the
draw it
answer
on the
at
test?
level.
Because I don't think I'm gonna be able to draw that.
You might have to draw it on the test.
Oh, wait.
What am I gonna say?
But you're definitely going to have to draw it in the homework. So get some good practice in the homework.
Oh, yeah.